This video covers section 11.2, exponential functions. Objective 1, evaluate exponential expressions. An exponential function is any function that has a base raised to some power. We like to start off with our base of 2. That's our standard exponential function, f of x equals 2 raised to the x power. So when we evaluate this function, f of negative 2, we're placing the exponent as negative 2. 2 to the negative 2 is 1 over 2 squared, or 1/4. So we're placing powers on 2. So that f of 2 is 2 to the second power, which is 4. F of 5 is 2 to the fifth power, which is 32. Going the other way, practice 2. Find the x value that would make us get to 128. We saw that 2 to the fifth is 32, which would make 2 to the sixth 64, which would make 2 to the seventh 128. So that would make x equal to 7 in order for 2 to the x to be 128. Letter B, 2 to the x is 1 over 32. If 2 to the fifth is 32, then 2 to the negative fifth is 1 over 2 to the fifth, or 1 over 32. So in this case, x would be negative 5. So we want to get a handle on our exponential functions. One of our goals is to see what the graph looks like. In order to see the graph, we want to evaluate this exponential function at several different x values and plot those points. So we already saw from the practice problems that 2 raised to the negative 2 is 1/4, so we would have negative 2 comma 1/4. We saw that 2 to the second power was 4, giving us 2 comma 4. If we want to plug in 0, 2 to the 0 power is 1. And 2 to the first power is 2. Third power, or 2 cubed, is 8. And 2 to the negative 1 is 1 over 2. 2 to the negative 3 is 1 over 2 cubed, or 1/8. So we see in the list to get bigger, we're multiplying by 2. 2 times 1 is 2, 2 times 2 is 4, 2 times 4 is 8, 2 times 8 is 16, and 32, and so on. To go the other way, we're dividing by 2. 1/2, 1/4, 1/8, 1/16, 1/32. If we change the base from 2 to 1/2, we see that when we plug in 0 as an exponent, we still get 1. So that hasn't changed anything. However, when we put in 1 for x, now we're at a half, 1, 1/2. When we plug in 2, that's 1/4, 2, 1/4. 3 cubed is 1/8, 3, 1/8. So what we see in comparison is that we're getting these numbers on the other side. We're flipping them so that when we plug in negative 1, we're going to expect these numbers. 1/2 to the negative 1 is 2. 1/2 to the -2 is 2 squared, or 4. And -3, 2 cubed is 8. Giving us -3, 8. So these are the two different kinds of exponential functions that we'll be looking at. An exponential function is any function of the form where you have a base, which we call a, raised to the x power. The restriction on a is that it can't be 1 and it needs to be greater than 0. So we break it up into two cases, one in which the base a is greater than 0, less than 1, and one in which the base is greater than 1. We see when the base is greater than 1, as x gets big, the function's values get big. And if a is between 0 and 1, as x gets big, the function's values get small. We can plug in any number we want as an exponent and get an output. So the domain of this exponential function is the set of all real numbers. We will see by the graph, and we can also see by the table, that the outputs that we get are always greater than 0. And this concludes the video for section 11.2, exponential functions. Objective 1, evaluate exponential expressions.